Okay, here we go. Part 2 of working with the factor theorem. In the previous lesson, we went and found out that the remainder theorem helps us, by way of the factor theorem, to help us find our factors of complex polynomials like we see up top here. If this question said, consider the polynomial p at x is equal to x cubed plus 2x squared minus 5x minus 6, determine the factors, we might not know where to start. In previous questions, they have asked us to try and see if it's a factor. They've given us a binomial and asked us to use remainder theorem / factor theorem to help us determine it. But in this case, they don't give us any numbers to try. But there is a little tip that we can pass on, and that is to focus on the last value, the constant, in each of the expressions. And this is the number that helps us determine what numbers we might possibly want to try. Now this method is called the integral zero theorem, and it's listed down here and it's written in your textbook as well. And the integral theorem works when we have a 1 in front here. There will be another theorem, very similar to this, that we can use when we have numbers in front, such as 2. But we'll get to that in a few minutes. The one way of using the constant to help us determine factors is to look at the factors of that constant. And so I know that 6 can be equal to 3 times 2, or it could be equal to 1 times 6, or negative 1 times negative 6, or negative 1 times 6, if in fact it's a negative in front. So one way of determining all of this, or determining where to start, is to look at the factors of 6. And so what we want to do is write out all the possible integers that we can try. And that's the reason they call it the integer zero theorem. There's no decimal numbers here, we're just trying integers. So once we've listed all of the factors, then we would move in and start to try. And so I'm going to start with 1 and see if that works. I'm going to try and do this a little bit in my head. So I have 1 cubed is 1 plus 2 minus 5 subtract 6, which is not equal to 0. I'm going to move to negative 1 next. I'm going to try negative 1, and I see that that's negative 1 plus 2 plus 5 minus 6, and that is in fact equal to 0. Now I stop and I want to use the factor of x plus 1 and write out my long division statement, because the question is determine all the factors. And so there might be some more. And so I would continue down this long division process. I'm going to carry this over to the next page so that we have a little bit more room to work on. So once again, we've determined that p at negative 1 is in fact equal to 0. Therefore, x plus 1 is a factor. It's important to state that. Next, we want to use our skills with long division and determine what the possible quotient might be. And we know there will be a quotient up here because we know the remainder will be 0. That's what this process up here has started for us. So we go through, once again, x squared times x gives us x cubed plus x squared. If we distribute, we subtract both values, we end up with x squared subtract 5x plus x squared plus x. Once again, subtracting negative 5 minus a positive is negative 6x. We bring down our final number, and we see in fact that the remainder is 0, which we knew all along. This in turn allows us to write our factors out. Don't forget the divisor, x plus 1, and their newfound quotient, x squared plus x minus 6. Because they want us to determine all the factors, we use simple factoring for trinomials to find out the other factors, and we see of x plus 3 and x minus 2. This is one method of factoring. And you can imagine if this was a quartic or a quintic, our long division line would get very long. What we also want to introduce is a second method of dividing binomials into polynomials. And this method is called synthetic division. Synthetic division is a process, and after we show you this, you might not ever use long division again. Synthetic division is a new step for most people, and the setup is really the new part. The math is quite easy. We have determined that p at -1 gives us a remainder of 0. So the way we set this up is we use kind of like an upside down division sign, and we place that -1 just to the left of this division sign, or upside down division sign. Then what we do is we're only concerned with the constants out in front. And those are the numbers that we place down. Now the same rules apply. If we're missing a term, we have to fill it with a 0, but luckily for us we're not. So I take the 1 from up here, followed by the 2, then the -5, and then a -6. Once everything, the constants are all written down, this is the steps that are involved. We always drop the first term down to the bottom. Then the process is we multiply these two together. -1 multiplied by 1. We put whatever the answer, whatever the product is, right below the next place. And then, very important, you add vertically. 2 plus -1 is 1. Then we repeat. Multiply. -1 times 1 is -1. Then you add. -5 plus -1 is -6. Then you multiply. -1 times -6 is +6. When we add this time, we get that remainder of 0. And quite often, a good habit is to draw a little bit longer line in between your remainder of 0. The result now is in fact the same constants we had when we did this using long division. So if you see up here, we have a 1, 1, -6. 1, 1, -6. What we need to do is fill in the variables so that when we're writing out the factors, we have x plus 1 from up here, followed by x squared plus x minus 6, exactly the same quadratic that we had in the long division question. And once again, we would factor to determine all the factors. This process is known as synthetic division. It's synthetic partly because you lack all of the variables that are there. So there is a detailed step. You can Google and search for different ways of synthetic division. I will point out, special note, that depending on the textbook you're using, they might change this number from a -1 to a +1. But if they do that, and you're writing out the numbers at the very top the same way, you will drop down the 1, but instead of adding, like we did here, you will subtract. I think the textbook shows you that way. So two different methods, the end result is the same. The very last thing we want to take a look at is what happens when we have polynomials with a number out in front other than 1. The same approach applies as we did when we used the integral zero theorem. The difference now is we may have possibilities of having more factors, and some of those factors may actually be fractions. So instead of just x minus 1 is equal to 0, we might have something like 2x plus 1 is equal to 0 factor. And what the integral zero theorem does is it helps us to determine what numbers to test again for factor theorem. So if I was to look at the combination of all of these, what I want to determine is all of the possible factors. And so when I'm looking at this, I still take a look at the constant, and I also take a look at the number in front. The values that need to be placed there are always going to be combinations of plus or minus the factors of b divided by the plus or minus the factors of a. So here is a, and here is b. So all of the factors that I'm looking at, and there are quite a few, are going to be listed down below. So a was equal to 3, b was equal to 2. And so when I'm looking at these numbers, I want to determine, so I can look at a and b. And so I can take the factors of b are plus or minus 1 and plus or minus 2, and the factors of a are going to be plus or minus 1, plus or minus 3. Now I can write each of these in the ratio form, that b over a. So here's a list of all of the possible factors, plus or minus 1 over plus or minus 1. That's this one over this one. Then I can take plus or minus 1 over plus or minus 3. And then I can work with the plus or minus 2 over plus or minus 1 and plus or minus 2 over plus or minus 3. I don't leave them in this form because I know that this can be simplified to just be plus or minus 1. This can be simplified to become plus or minus 1 over 3. 2 over 1 is the same thing as plus or minus 2. And plus or minus 2 over 3. So it cleans up a little bit better. Now, the last little hint is when you're starting to determine the factors, I would look at plus or minus 1 as possible factors before I worked with the fractions. Unless, of course, you love fractions.